Dear students, welcome to the video Past Examinations Paper Solving Mathematics 9709 Pure Mathematics 1 AS Level Paper 1-2 May June 2022. Question number 1. The coefficient of x to the power of 4 in the expansion of 3 plus x to the power of 5 is equal to the coefficient of x squared in the expansion of 2x plus a over x to the power of 6. Find the value of the positive constant a. First, let's find coefficient of x to the power of 4 in this expansion. We have two terms in the brackets, 3 and x. So 3, the second term is x, and you have one combination before. But it says coefficient of x to the power of 4. So x takes power 4, and we know that in the expansion of binomials, the two terms, whatever power they have, it should add up to this power, which is 5. As x takes power of 4, so 3 should have power 1, because 1 plus 4 add up to 5. So the expansion n is 5 here, so it will be 5 C4. However, there is no difference between 5C4 and 5C1. So if you find the coefficient, it will be a combination of 5. C4 is 5 times 3 times x to the power of 4, so it is 15 x to the power of 4. Now it says is equal to the coefficient of x squared in the expansion. So you have two terms here, 2x a over x and one combination before. As you know, it should simplify to x squared, and the sum of powers should add up to 6. We should choose 4 as the first bracket power and 2 here, because it produces x to the power of 4, here x squared in denominator, then it will simplify to x squared, and here you have 6c2. So 6c2 is equal to 15 multiplied by the expansion of these brackets will be 2 to the power of 4, which is 16, times x to the power of 4 multiplied by a squared x squared. They simplify to x squared, so it will be 240 a squared x squared. So next step, it says these two coefficients are the same. Coefficient of x4 in this expansion, which is 15, is equal to coefficient of x squared in this expansion, so is equal to 240 a squared. So if you simplify, if you divide both sides by 240, a squared will be 15 over 240, which is equal to 1 over 16. If you take a square root, a is equal to positive negative 1 over 4, as it says positive, so a will be 1 over 4 as the final answer for this question. Question number 2. The second and third terms of a geometric progression are 10 and 8 respectively. Find the sum to infinity. As the second term, so second term is 10 and third term is 8. We know that in geometric progression, it's actually definition of geometric progression. The ratio between any two consecutive terms is a constant, which is called common ratio. So R can be written as a3 over a2, the ratio between third and second term. There are two consecutive terms, so it is 8 over 10, which simplifies to, if you divide both by 2, it will become 4 over 5. So R is 4 over 5. So the formula of second term is AR. So in order to find the first term, we can write A2 second term over R. A2 is given 10. Second term is 4 over 5. Which simplifies to 50 over 4 or 25 over 2. So it is the first term of this progression. So the formula of sum to infinity. We know that it is this progression is convergent because r is between 1 and -1, so is less than 1. So it can be written as a over 1 minus r. A is equal to, we found it here, 25 over 2 over r is 1 minus 4 over 5, which is 25 over 2 over 1 over 5, which is equal to 125 over 2. This is the sum to infinity for this progression. Question number 3. The equation of a curve is such that dy dx is equal to 3 4x minus 7 to the power of half minus 4x to the power of negative half. It's given that the curve passes through the point 4 and 5 over 2. Find the equation of the curve. As a derivative of a function is given, in order to find the function y, we need to integrate 3 4x minus 7 to the power of half minus 4x to the power of negative half with respect to x. So y will be equal to, so in order to integrate the first expression, it will be 3. A is 4, so it will be 1 over 4 multiplied by 4x minus 7 to the power of half plus 1, which is 3 over 2 over 3 over 2 minus 4x to the power of negative half plus 1, which is 1 over 2 over 1 over 2 plus a constant c. So y will be equal to, if you simplify here, 3 over 2 comes up and becomes 2 over 3, 3 and 3 cancel out each other. It will be 2 over 4, which simplifies to 1 over 2, 4x minus 7 to the power of 3 over 2 minus 4 over 1 over 2 becomes 8 root x plus c. It is the function with c as unknown, but you're given a point satisfying the curve for and 5 over 2, so I replace it. So y is 5 over 2 is equal to 1 over 2 4 times 4, which is 16, minus 7 becomes 9 to the power of 3 over 2 minus 8 root 4 plus c. So it becomes 5 over 2 is equal to, 9 is 3 over 2, so 2 and 2 cancel out, it will be 3 to the power of 3, which becomes 27 over 2 minus root 4 is 2, so minus 16 plus c. So c will be equal to 5 over 2 minus 27 over 2 plus 32 over 2. C will be then 5. So the function becomes 1 over 2 4x minus 7 to the power of 3 over 2 minus 8 root x plus 5. This is the final answer to this question. Question number 4. The first, second, and third terms of an arithmetic progression are k, 6k, and k plus 6, respectively. Find part A, the value of constant k, part B, the sum of the first 3 terms of the progression. For part A, we know that in arithmetic progression, the difference between any two consecutive terms is a constant shown by D, common difference. So the difference of second minus first is to be equal to the difference between k plus 6 minus 6k. So on the left hand side you have 5k. On the right hand side it will become negative 5k plus 6. So it will be 10k is equal to 6, so giving you an answer of 0.6 as k. So k is 0.6. So first term was k, so is 0.6 as the first term. And d is the difference between 6k minus, which is second term, minus first term, which is 5k. So k is 0.6. So common difference is 5 times 0.6, which is equal to 3. So part B wants you to find the sum of the first three terms. So S30 is equal to 30 over 2 2a, which is 2 times 0.6 plus n minus 1, which is 29, multiplied by d, which is 3. So the final answer is 1323. Question number 5. The equation of a curve is y is equal to 4x squared minus kx plus half k squared. And the equation of a line is y is equal to x minus a, where k and a are constants. Part A, given that the curve and the line intersect at points with x coordinates 0 and 3 over 4, find the values of k and a. Part B, given instead that a is equal to negative half 7 over 2, find the values of k for which the line is a tangent to the curve. So that these actually 2 points satisfy both line and curve. We know that in order to find points of intersection, we need to solve simultaneous equations. So these two curves and line meet each other at these 2 points. So in both of them, y is already the subject. I simply put them equal to each other. Minus kx plus half k squared is equal to x minus a. So one of the points at which they intersect is 0. So it means that x is equal to 0 satisfy this equation. So if you replace x by 0, so it will become half k squared is equal to negative a. One equation. Now the second point at which they intersect is x is equal to 3 over 4. So I replace it, 3 over 4 k times 3 over 4 plus half k squared is equal to 3 over 4 minus a. So it will simplify to 9 over 4 minus 3 over 4k plus half k squared is equal to 3 over 4. We know that minus a is equal to half k squared. So I replace it to have one unknown. So they simplify each other. So it will become 6 over 4 is equal to 3 over 4k. 4 and 4 cancel out, giving you an answer of 2 4 k, part A. Now for part B, it says given that a is negative 7 over 2. So we have this equation for x squared minus kx plus half k squared is equal to x, and a is given negative 7 over 2, so it will become plus 7 over 2. I transfer whatever I have to one side, so it will become 4x squared. You have minus kx minus x, I factor minus k plus 1 x is equal to sorry, I should transfer 7 over 2 to the left hand side. 1 over 2k squared minus 7 over 2 is equal to 0. So a will be 4, b is minus k plus 1, and c is half k squared minus 7 over 2. Now we know that when the when a line is a tangent to the curve and you solve this equation, discriminant should be 0 because they actually produce repeated roots. So discriminant should be 0. Now minus k plus 1 whole squared minus 4 times a times 1 over 2k squared minus 7 over 2 must be 0, which simplifies to this equation, minus 7k squared plus 2k plus 57 is equal to 0. You can factorize 7k plus 19 times minus k plus 3 will be factorization, so one root is negative 19 over 7 and the other root will be 3. This is the answer to this question. Question number 6. The diagram shows the curve with equation y is equal to 5 x to the power of half and the line with equation y is equal to 2x plus 2. Find the exact area of the shaded region which is bounded by the line and the curve. In order to solve this question, first thing to do is to find the points of intersection. These 2 points as a lower and upper bound of this shaded region. So we need to solve the equation 2x plus 2 is equal to 5x to the power of half. I transfer 5x to the power of half to the left hand side and write in order 2x minus 5x to the power of half plus 2 is equal to 0. So I use substitution. Let x to the power of half be, for example, a. So equation turns to be, and then x will be a squared. So it will be 2a squared minus 5a plus 2 is equal to 0. So if we factorize, it will become minus 1 here, minus 2 here is equal to 0. A is equal to half, and 2 in order to find x is a squared, so is 1 over 4 as the lower bound and 4 as the upper bound of the region. So this point is 1 over 4 and the second point of intersection is f4. Now let me change the color for different steps. Now in order to find the area of this shaded region, we need to calculate the area under this curve. Then we need to subtract area under this line from the whole region. This white region must be deducted from the region below this curve. So it will be integration of lower bound, which is 1 over 4 up to 4. The curve is above the line, so 5x to the power of half minus the line, area under the line, 2x plus 2 d of x. It will simplify to integration of 1 over 4 till 4, 5x to the power of 1 over 2 minus 2x minus 2 dx. So if we integrate, it will be 5x to the power of 3 over 2 over 3 over 2 minus 2x to the power of 2 over 2 minus 2x. For definite integrations, we don't need to add c here because they cancel out each other when you substitute upper bound and lower bound. So this integration will simplify to 10 over 3x to the power of 3 over 2 minus x squared minus 2x 1 over 4 till 4. Now I substitute 4 is 2 squared. If I replace x by 2 squared, a squared and this 2 of denominator cancel out each other, it will be 2 to the power of 3, which is 8 actually. So 10, let me first write the substitution. 4 to the power of 3 over 2 minus 4 squared minus 2 times 4 for the upper bound, and for the lower bound 10 over 3, 1 over 4 to to the power of 3 over 2 minus 1 over 4 squared minus 2 times 1 over 4, which simplifies to this becomes 80 over 3 minus 16 is 3 minus 8 minus 4, it will be 2 squared, again the same logic will be implemented here. It will be 1 over 2, so it will be 10 over 24 minus 1 over 16 minus 2 over 4, which is 1 over 2. If we calculate this expression, it will become 135 over 48, which is equivalent to the mixed number 2 and 39 over 48. Let me fix this 8. So this is the final answer for this question. Question number 7. The diagram shows a sector OBAC of a circle with center O and radius 10 centimeters. The point P lies on OC and BP is perpendicular to OC. Angle AOC is pi over 6 and the length of the arc AB is 2 centimeters. Part A, find the angle BOC and part B, hence find the area of the shaded region BPC, giving your answer correct to 3 significant figures. To answer part A, it's given that length of arc AB is 2 centimeters. We know that when angle is in radians, so length of arc is r theta. So AB, length of arc, is r theta, which is included angle. Angle actually be OA. So I replace 2 is equal to radius is 10 times our angle is actually a OB. It will give you rad. So a OB will be equal to 2 over 10, which is 1 over 5 radians. So we found this angle. In order to find the angle BOC, we need to add these two. So BOC is 1 over 5 plus pi over 6 rad for part A. Now, for part B, in order to find the area of this shaded region, we need to find area of the sector. I find first area of sector. Then I will deduct area of this triangle from the sector. It will give you the area of the shaded region. So I first find area of the sector. So it will be half of r squared theta, half of 10 squared multiplied by the included angle. So it will be actually 1 over 5 plus pi over 6, giving you an answer of 36.18. Now, in order to find area of the triangle, triangle OBP, so we need to find first side OP. So in order to find side OP, I use cosine of this angle. So cosine of this angle, which is 1 over 5 plus pi over 6, is equal to adjacent, which is OP, over hypotenuse, which is 10. So OP will be 10 cosine of 1 over 5 plus pi over 6. It will give you 7.49 centimeter, and this is centimeter squared. Now, in order to find area of triangle OBP, I use the formula in which sine is used, 1 over 2 multiplied by OP, which is 7.49 multiplied by 10 multiplied by sine of included angle, which is 1 over pi 5 plus pi over 6, which will give you as this area will be 24.80 centimeter squared. It is the area of this triangle. To find area of the shaded region, it will become 36.18 minus 24.80, giving you answer of 11.38, which is 4 correct to 3 significant figure 30 cm squared. Question number 8, the equation of a circle is x squared plus y squared plus ax plus by minus 12 is equal to 0. The points A with coordinates 1 and 1 and B with coordinates 2 and negative 6 lie on the circle. Part A, find the values of A and B, hence find the coordinates of the center of the circle. Part B, find the equation of the tangent to the circle at the point A, giving your answer in the form of px plus qy is equal to k, where p, q, and k are integers. As A and B lie on the circle, so it means that these 2 points satisfy equation of the circle. So I replace A first. It will be 1 plus A plus B minus 12 is equal to 0, which simplifies to A plus B is equal to 10. I replace 2 and negative 6, so it will be 4 plus 36 plus 2A minus 6b minus 12 is equal to 0. Simplifies to equation 2a minus 6b is equal to negative 28. So a plus b is equal to 10. You have a pair of simultaneous equations. So these terms are all divisible by 2. So it will be a minus 3b is equal to minus 14. I subtract these two equations, so a and a cancel out. 4b is equal to 24, then b is 6. So b is 6, replacing in the first equation, a will be 4 now. So I rewrite the equation, it will be x squared. Now I write ax next to x squared. A was 4, so x squared plus 4x plus y squared plus 6y. I transfer 12 to the other side. Now I make these two pairs of complete square form. It will be x plus 2 s squared minus 4. For the second one, it will be y plus 3 squared minus 9 is equal to 12. Then it will simplify to x plus 2s squared plus y plus 3s squared minus 4 minus 9 minus 13. It added to 12, it will be 25. So center will be the roots of these two brackets. Roots of x plus 2 is minus 2, and likewise here negative 3, and r, which is radius, is root of 25, which is 5. This is the answer to part A. For the second part, I first construct a circle. So here is the center, which is negative 2, negative 3, and here, for example, here is center, point A, 1 and 1. Now, you're supposed to find the equation of the tangent to the circle at point A. So this will be our tangent, which makes an angle of 90 here. So first I find equation of AC. So which is 1 minus 3, which is 1 plus 3 over 1 minus 2 plus 2, which is 4 over 3. So for the tangent, we use a negative reciprocal, which is negative 3 over 4. So equation of the tangent will be y minus 1 is equal to negative 3 over 4 x minus 1 minus 1. So if you expand and transfer to the left hand side, it will be y plus 3 over 4 x is equal to 3 over 4 plus 1. So it will be y plus 3 over 4x is equal to 7 over 4. Now you're supposed to write in this form, and all coefficients are to be integers. So to get rid of this denominator, I multiply all by 4. So it will be, here I write in the same order. So it will be 3 over 4 times 4. 4 cancels out, so it will be 3x plus 4y is equal to 7. It is the final answer for the second part. Question number 9, the equation of a curve is y is equal to 3x plus 1 minus 4 brackets 3x plus 1 to the power of half for x greater than negative 1/3. Find dy dx and the square root of y with respect to x squared. Part B, find the coordinates of the stationary point of the curve and determine its nature. For part A now, you're looking for dy dx. So we differentiate simply. Differential of 3x is 3, 1 is 0, so minus 4. In order to differentiate this binomial, so you have the coefficient, then differential of brackets, which is 3, then you have the power, then 3x plus 1 to the power of 1 over 2 minus 1, which is negative half, which simplifies to 3 minus 6, 3x plus 1 to the power of negative half. And for the second part, the square root of y with respect to x squared, I differentiate this expression. Differential of 3 is 0, so minus 6 multiplied differential of brackets, which is 3, times negative half, 3x plus 1 to the power of negative half minus 1, negative 3 over 2, which simplifies to, and 9, and 3x plus 1 to the power of negative 3 over 2 as the answer for part A. The second part, we need to find root first. In order to find the coordinate of the stationary point, first we find the root of differentiation. First differentiation 3. So I write in this form 3x plus 1 root is equal to 0. So root of 3x plus 1 must be 2. So 3x plus 1 is 4. X is 1. As it is within the domain, more than negative 1/3 is acceptable. X is 1. To find y coordinate are replaced in the original equation. So it would be 3 plus 1 minus 4 brackets 4 to the power of half, which is negative 4. So a stationary point coordinates actually are 1 and negative 4. In order to determine its nature, to find whether it's mean or max, we replace x coordinate in the second differentiation. So dy squared, the square root of y with respect to x squared, will be equal to, when x is actually 1, will be equal to, I replace here, it would be 9 over 3 plus 1, which is 4 to the power of positive 3 over 2. It is transferred to the denominator with positive power. So it is simply more than 0. So when it is more than 0, it means that the curve bends upwards at that point. So it will be a point of mean, the point 1 and negative 4. It is the final answer for this question. Question number 10. Functions f and g are defined as follows. F of x is equal to 2x plus 1 over 2x minus 1 for x other than 1 over 2. G of x is equal to x squared plus 4 for x belongs to are all real numbers. You have, it says part A, the diagram shows part of the graph y is equal to f of x. State the domain of f inverse. Now, in order to find domain of f inverse, we know that domain of f inverse is equal to range of f. Now, what is range of f? You see, this graph takes all numbers other than 1. So domain of f inverse will be equal to all real numbers other than 1, because see, it is going to actually touch 1. It is actually approaching 1 from top. This y is equal to 1 is horizontal asymptote. It doesn't actually cut, it just approaches this line. So it goes up to positive infinity, and from down negative infinity, every number other than 1. So it is all the numbers other than 1 for part A. To do part B, it says find an expression for f inverse of x. So first I replace f of x by y. Y is equal to 2x plus 1 over 2x minus 1. I do cross multiplication, it will be 2xy minus y is equal to 2x plus 1. I'm going to make x the subject. I transfer 2x to the left hand side. 2xy minus 2x is equal to 1 plus y. I factor x. 2y minus 1 is equal to 1 plus y. 2y minus here 2. Then x will be 1 plus y over 2y minus 2. To express f inverse in terms of x, I replace x by y. 1 plus x over 2x minus 2 as the answer for the second part. Part C, you're supposed to find g of f inverse of 3. We found equation of f inverse of x in the previous part, which was x plus 1 over 2x minus 2. I first find f inverse of 3, so it is 3 plus 1 over 4, which is 1 actually. So we are supposed to find, so f inverse of 3 is 1, so g of f inverse of 3 is equivalent to g of 1, which is equal to 1 squared plus 4, giving you an answer of 5. Part D says explain why g inverse of x cannot be found. So as x squared plus 4 is actually such a graph, x axis, y axis. Graph of x squared is parabola, a smiley face, 4 units up, so 1 2 3 4. It has actually such a shape, so x squared plus 4. You clearly see that if you construct horizontal line, it cuts twice, so it is not 1 1. That's why it cannot, it's not invertible actually. Part E says show that 1 plus 2x 2 over 2x minus 1 can be expressed as 2x plus 1 over 2x minus 1. Hence find the area of the triangle enclosed by the tangent to the curve y is equal to f of x and points where x is 1 x-axis and y-axis. So I first construct a tangent. X is equal to 1 is this point. Now it is going to make the actually tangent to the curve. Now it is the required, if I extend also y-axis for you to clearly see the triangle here. This is the triangle. So in order to find the area, we need to have first equation of this line, which is tangent to the curve, in order to find base and height. Then you can simply find the area. So first we are supposed to show that these two expressions are equivalent. So 1 plus 2 over 2x minus 1. I give a denominator of 1. So I take a common denominator. Both denominator and numerator are multiplied by 2x minus 1. So it will be 2x minus 1, numerator 2x minus 1, plus 2, which simplifies to 2x plus 1 over 2x minus 1. Why actually we did so? In order to find gradient of the tangent, we need to differentiate f of x. But students in AS level do not learn how to differentiate such functions, as the quotient rule must be implemented, and students in Cambridge system learn quotient rule in A2 level. So that's why we can instead use the equivalent expression. So I use this function to differentiate 2 to x minus 1 to the power of negative 1. So I differentiate it. Differentiation of 1 is 0, but differentiation of this expression is 2 multiply. Differentiation of brackets is 2 multiply power, then 2x minus 1 to the power of negative 2, which becomes 4, actually negative 4 over 2x minus 1. It will be a gradient formula, but m at point 1 where x is 1, so it will be negative 4 over 2 times 1 minus 1, which is 1, so it is negative 4 actually. So it is the gradient of these actually tangent to the curve at point x is equal to 1. Now, so we have x coordinate, x is 1. Let's find y coordinate. So y will be, I replace it here. You can use this or the second one. So it will be 2 plus 1, which is 3, over 2 minus 1, which is 1. So it is 3. So point is 1 and 3. Now, equation of the tangent will be y minus y1, y minus 3 is equal to negative 4, x minus 1. So it will be equal to minus 4x. Minus 4 minus 1 will be positive 4 plus 3 plus 7. It is gradient of the equation of the tangent. Now we need to find now these 2 points. So I label this point A, this point B. To find B, x is 0. So if x is 0, y will be 7. So this point is 7. To find A, x coordinate of A, y will be 0. So if 0, it will be, let me change it to A. 0 is equal to negative 4x plus 7. So x will be 7 over 4. So this is 7 over 4. Now, to find the area, half of base, which is 7 over 4, times height, which is 7. So it will be 49 over 8 as the area of this triangle. Question number 11, the function f is given by f of x is equal to 4x to the power of 4x plus cosine squared of x minus k. X is between 0 and 2 pi, where k is a constant. Part A, given that k is equal to 3, find the exact solutions of the equation f of x is equal to 0. So k is replaced by 3, so it will become 4 cosine to the power of 4x plus cosine squared of x minus 3 is equal to 0. Now, I rewrite it. I want to convert it to quadratic equation. Cosine squared of x squared plus cosine squared of x minus 3 is equal to 0. Now let cosine squared of x be, for example, c. So it will turn to 4c squared plus c minus 3 is equal to 0. Now if you factorize, it will be factorized to 4c minus 3 times c plus 1 is equal to 0. So c will be 3 over 4 and negative 1. So we have 2 equations to solve. I replace back cosine squared of x, which is c. Once is 3 over 4. 1 cosine squared of x is negative 1. As a square of no number gives you a negative value, so it doesn't give you any answer, so we do this one. So we take a square root, So cosine of x will be once positive root of 3 over 2 and once negative root of 3 over 2. Now, so x will be cosine inverse of root 3 over 2, which is pi over 6, and x will be cosine inverse of, for this one, negative root 3 over 2, giving you 5 pi over 6. Now for cosine, the other answer will be negative pi over 6, here negative 5 pi over 6. Then to find the other answers, so 1 pi over 6 plus 2 pi, 1 pi over 6 minus 2 pi, 1 negative pi over 6 plus 2 pi, 1 negative pi over 6 minus 2 pi. And we do the same here, negative, first 5 pi over 6 plus 2 pi, 5 pi over 6 minus 2 pi, negative 5 pi over 6 plus 2 pi, and negative 5 pi over 6 minus 2 pi. Now, let me change the color. Here, this one is acceptable, this one is not, because it says between 0 and 2 pi. This one, it will go beyond the interval, this one not, but this one yes, it will be 11 pi over 6, this one no, this is acceptable, this is not, this is not, this is not, but this one will be 7 pi over 6, which is acceptable, and this one no. So final answer as x is pi over 6, 5 pi over 6, 11 pi over 6, and 7 pi over 6. These are the 4 answers for the part. Now for part B, it says use the quadratic formula to show that when k is greater than 5, the equation f of x is equal to 0 has no solutions. So I rewrite the equation for, I write cosine squared of x squared, I write in the form of a quadratic equation because it says quadratic formula, plus cosine squared of x minus k is equal to 0. Now in this quadratic equation, a is 4, b is 1, c is negative k. C, it is your new unknown, actually, as if it is your, for example, a. It's a quadratic equation, 4a squared plus a minus k is equal to 0. But I keep cosine squared in the equation. Now, in order to find unknown, which is cosine squared, or a, is minus b plus minus root of discriminant, which is b squared, 1 squared, minus 4 times minus k. So over 2a, which is 8. So cosine squared of x is equal to minus 1 plus minus 1 plus 16k over 8. Now, let me construct a graph of cosine of x first. We are in the interval 0 till 2 pi. So, for example, pi over 2, pi, 3 pi over 2, and 2 pi. We know that cosine of x varies from positive 1 until negative 1. Let me change the color for cosine of x. So, cosine of 0 is 1. Then comes to negative 1, then 0, then again 1. This is graph of cosine of x, but our equation is cosine is squared of x. So let me use a black color. So a squared makes negative part actually reflected in x-axis, it becomes these positive parts remain the same, but these will be reflected. Then so this black one is the graph of cosine squared of x. Now we know that cosine of x varies from +1 to -1, but cosine squared of x is between 0 and 1. So -1 plus minus root of 1 plus 16k over 8 is between 1 and 0 because it is cosine squared. Now, so if this expression takes values between 0 and 1, so the equation will have answers. But if it is out of this range, for example, ones with positive, -1 plus 16k over 8 is less than 0, or if -1 plus -1 plus 16k over 8, if it is more than 1, outside of this interval, so it won't produce any solutions. Now to solve this inequality, I multiply both sides by 8, so it will become 1 plus minus square root of 1 plus 16k. 8 times 0 will be 0, so plus minus square root of 1 plus 16k. -1 is transferred, so it will be 1. I square both sides to get rid of square root, so 1 plus 16k is less than 1. 1 and 1 cancel out, so 16k is less than 0, or k is less than 0. So if k is less than 0, this equation won't produce any solutions. Now for this one, I again multiply by 8, so it would be -1 plus minus the square root of 1 plus 16k more than 8. I transfer -1 to the other side, so it will be 1 plus 16k more than 8 plus 1, which is 9. I square both sides, so no matter positive or negative, when you square both will become positive, so it will become 1 plus 16k. 16k is more than now 81. Square both sides, so if you subtract 1 from both sides, so 16k is more than 80, or divide both sides by 16, it will be 5. So if k is more than 5, this equation won't have any answer. So in two cases, once k is less than 0 or k is more than 5, this equation won't produce any solutions. Thanks for watching this video.